Alright, so today we're going to get started by drawing Lewis structures, and the first step in drawing Lewis structures is identifying valence electrons. So we're going to go back to Unit 2 and we're going to start with the basics. Okay, so either using the drawing feature or you can just write the answers. How many valence electrons do each of these elements have? Okay, you can either write the answer or draw the Lewis structure or both. Okay, and on your Google Classroom, you have a few different periodic tables. If you look in the classwork tab, there's a topic called General Materials. And I never called your attention to this, but here it is. The first thing is a quick link. So if you need a link to the Zoom call, office hours, our emails, anything like that, I put this together so it's all in a one-stop shop if you need it. You have that there. But then more importantly for today in class is underneath it are periodic tables, and there's 4 different versions, okay? We have the Regents periodic table, which we've been using mostly in class. We have the one we learned at the very beginning of the year with the names on it. We have the one we made together, which is my favorite periodic table ever. And then I also have a Regents one, but this time color-coded with metals versus non-metals if you need it, okay? So very good job, my friends. As a reminder, when finding valence electrons, what you're going to do is you're going to utilize your Regents periodic table, which literally gives the answer to you, and you're going to look at your electron configuration, and valence electrons is the last number. So it's going to be the number 4, spoiler alert here, for carbon. Okay, very good job. Give you guys about 30 more seconds. Few of us went the naming or the writing the numbers route. A lot of us went the drawing the electrons route. Whatever works for you. Okay? Alrighty, so I'm gonna lock your screens here in just a moment, and I'm gonna show you 2 versions of this answer. One with the dots and one with just writing the numbers. Either one is fine for today. But if you peek on over to the Zoom screen share, you will see 2 answers and they match each other. We have carbon here with 4 valence electrons, so it has 4 dots. Nitrogen with 5, hydrogen with 1, oxygen with 6, and fluorine with 7. Okay, I appreciate the color coding, but even more so, I appreciate how you spaced out your electrons here, where you want to remember you draw the 4 on the top, bottom, and the sides, and then they start pairing up. That is going to be very helpful when trying to figure out how to put the puzzle pieces together when drawing Lewis structures. Okay, so why is this important when we're drawing covalent compounds? The first part in drawing covalent compounds is you need to know how many total valence electrons you have. And so, for example, if I have a compound with carbon and nitrogen, you would add these 2 numbers up, multiply if you have a certain number of each one. Okay, and so you need to be able to find the valence electrons as step number 1. Okay, the second step you were introduced to in your ed puzzle yesterday, and it is identifying the atom that will go in the center. Now, in the ed puzzle yesterday, they went real fancy with it. They were throwing out terms like electronegativity, but more importantly, they gave you a little shortcut. So I want you to see what you can do. We have 3 compounds. These are the 3 that we are going to attempt to draw in class today. My last class only got to 2 of them, which is totally fine. And I want you to tell me which one you think will go in the center. You can either use an arrow, you can circle it, but between each of these compounds, OF2, NBr3, and H2S, which one of the elements will go in the center of the compound? Okay, you can circle it. My last class liked arrows. Somebody used the yellow highlight feature. Which one do you think will go in the center? Ooh, if you're drawing in red, you're jumping ahead, but you're on the right track. Actually, leave what you've drawn for red. All right, very good. So I'm going to go ahead and lock your screens. Somebody's getting very excited and doing a lot of the future work. It's like you're reading my mind. But if we take a peek on over at the Zoom screen share, we will see a pretty overwhelming consensus where oxygen is in the center for OF2, where nitrogen is in the center for NBr3, and where sulfur is in the center for H2S. I wanted to find the one that had them highlighted because that one was very easy to read. Oh, we have some arrows. Oh, here's the one that's highlighted. Very good. So if we look at these 4 answers from your classmates, they're all identifying the same thing, and this is exactly correct, okay? In the video yesterday, they talked about how you can use electronegativity to determine which one will go in the center, but in Regents chemistry, it's even easier than that. When you are looking at identifying who's going to go in the center, it's always going to be the one that you have only one atom of. Okay, so for example, OF2, there's an invisible letter number 1 after that O. So that guy is going to go in the center. NBr3, there's an invisible number 1 after the nitrogen, so it's going to go in the center. Same over here with sulfur, there's an invisible number 1, it will go in the center. The reason for this is because systems in nature, like if you look at anything that's in the natural world, they always want to be as symmetrical as possible. So same thing goes for covalent compounds. If you have a center atom that's different, it'll go in the center and all the others will surround it. Okay, if you look at flowers, they're perfectly symmetrical in one way or the other. Snowflakes are symmetrical. The human body is symmetrical in that you either have 1 of something or 2 of something, and it kind of lines itself up that way. Okay, the reasons why, we don't really know. It has to do with like physics and just like growth and yada yada, but just systems in nature want to be as symmetrical as possible. And so the same applies with covalent compounds and looking for who's gonna go in the center. Okay, if you are ever unsure, just let me know and I'll help you out, or it'll be whatever you have 1 of. Because in Regents Chem, we're pretty much going to be dealing with these pretty basic compounds where you only have 1 of one element and then who knows how many of another, but you'll be able to pretty easily identify who goes in the center. Okay, so at this point, my friends, you have a couple of options. You can either follow along with me on this screen share. We're going to actually try and draw as many of these compounds as we can. We're going to start with OF2, and we're going to draw them from scratch. I am also going to leave the Pear Deck slides open on the draw feature where you can draw them from scratch if you would like. If you think like, let me try it, I think I got it, you're welcome to do that, okay? But if you feel like, I want to see her do an example, just peek on over to the Zoom screen share. I'm going to share on my iPad and I'll be able to walk you through the whole process from beginning to end and kind of show you some of the tricks that I like to use to help me draw these structures. Okay, the first of which trick is this little template that I made. Okay, you'll notice I have like these rectangles and circles and random. I just made this up to kind of help keep myself organized when I taught this for the first time, okay, many moons ago. Okay, don't worry about it, George, it's okay. And so you don't need to use this template, but I have found it helpful for students to kind of keep their stuff organized, primarily the electrons, because it can be very easy to lose some of your electrons, to lose count of some of your electrons. And so this template, that's the main goal of this template, to be perfectly honest, is to keep track of those, okay? I have to sneeze. So we're going to start with OF2. And so if you're on the Pear Deck, you can try and draw this on your own, or you can follow along with me here on the screen. Okay, the first thing that you're going to do is you're going to look at your valence electrons. Thank you, Naomi. And we just went through how to do this. Oxygen has 6 valence electrons. Fluorine, we didn't look over, but it has 7 valence electrons. It's in group 17. And what do I need to do with this number 7 to account for this whole compound here? Because I can't just do 6 plus 7. That's not going to work out. What do I need to do here? You can either type in the chat. Thank you, Alex. You're going to multiply it by 2. The reason we're going to multiply it by 2 is because we have 2 fluorines. Okay, so this is going to give us 6 plus 7 times 2 is 14, which means we have a total of 20 electrons to work with. I like to put that up here in this top circle just so I can keep track of how many electrons I've used and how many I have left. Okay? And so what we're going to do next is we're going to follow the same process they talked about in the Ed puzzle yesterday, but there's actually several different ways to go about drawing Lewis structures. Some students like to draw the Lewis dot diagrams for each, like we just did in the warm-up question, and put the puzzle pieces together, but most people are going to get comfortable with what they were talking about in the video yesterday, so that's what I'm going to do here, okay? Whoever's drawing in purple, it's like you're reading my mind. You're doing exactly what I'm going to do next on the pear deck, so great job. And so the first thing you're going to do in the video yesterday is they said, start with your central atom and draw a single bond between it and all surrounding atoms. This is because you know that you're dealing with a compound where atoms are bonded together. So you know that the center atom is going to be sharing at least 2 electrons with each atom on any side of it. Okay, and so that's where I like to start. You can either start with the dots, or on this side, I'll do the same thing but with a line. Okay, the dots and the lines, 1 line equals 2 dots. Okay, I'm actually not going to do that because I don't want to confuse anybody. And so I'm going to keep tally. I just drew 4 electrons, so now I have 16 left to work with. Okay, and so what we're going to do now is utilize the octet rule to figure out where the rest of these electrons go. I like to just go right to left. It's easier for me, or left to right. Whatever, you know what I mean. And just kind of go in order. So how many more electrons does this fluorine need to be happy in this compound? Okay, right now it has 2 that it's sharing with oxygen. Okay, George, it does in general need 1, but to finish it in this picture, it is missing 6. Okay, I will show you where the 1 comes from. If I draw this in orange, the orange electrons are the one that came from this fluorine here. Okay, and so it needed 1 more, which it got by sharing with oxygen here. Okay, and so now this fluorine is happy. We drew 6 more electrons, and so now we have 10 left to work with. Okay, now I know I just said I like to go left to right like I'm reading a book, but in reality, I like to go with symmetry. The F here on the other side also only has 2 electrons, so I'm going to give it 6 more. And I'm going to color code that last one of the ones that's being paired to show myself and my reader, whoever needs to be shown. iPad, let's go. Why won't it let me draw on this picture? Here we go. Okay, so I drew 6 more electrons. So now I have 4 left to work with. Yes, you can use lines if you want, and you do not need to color code or anything like that. You can just use lines and dots all one color if you want, okay? I'm just color coding to kind of show people the process, okay? And so now we have to ask ourselves, where are those extra 4 electrons going to go? Where are they gonna go? Does anybody know? Most people, I think, are drawing in the pear deck. Very good, Starlin. Thank you, Alex, as well. We can't forget our central atom. The central atom is often the one that gets forgotten, and you want to make sure you check it as well. This oxygen right now, as it is drawn, currently has 4 electrons in its structure. It just so happens to need 4 more. And so what we're going to do is we're not going to draw the electrons here in between the letters, because that implies that they are being shared. What we're going to do is draw them as lone pair electrons and draw them just with the oxygen. So in this picture, it's the top and the bottom. And we drew 4 more electrons, so now we have used all of them, yay. And if you look at this in a few different ways, this oxygen is now happy with 8 electrons. This fluorine is now happy with 8 electrons. So was the orange one, we checked it as well. And I'm just going to go through and double check one more time that I've drawn 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 electrons, which is exactly the number we needed to draw earlier. Okay, so this picture, we've done the heavy lifting. We've done most of the work. The last thing that we're going to want to do is make it look a little bit neater. which you can do, or because you're just learning right now, it's day 1, you are welcome to leave it as is. Oh, I can't do that. Duh. Go back. Go back. Go back. Thank you. I want to get rid of these circles. They are not proper for final Lewis structures for covalent compounds. Or you can leave them if you want, but for today you can leave them, but moving forward you want to erase them. And this is perfectly acceptable as a final picture. Or somebody asked in the chat, can I replace these dots with a line? And the answer is yes. Okay, you can take anywhere that electrons are being shared and change those into lines, as you will see me drawing down here at the bottom. What you don't want to do is forget these electrons on the sides, and don't change those to lines. Lines are only going to be showing electrons that are actually being shared. Okay, and so either one of these pictures here that I have just drawn is acceptable for the final Lewis structure for OF2, oxygen difluoride. Okay, so at this point, to be respectful of time, I'm going to walk through what your asynchronous work is going to be for today. But if you feel that you want to walk through a couple more examples with me, you're welcome to stay here in class. But I know that some of you got this, you don't need help from me. So I'm going to show you what the async work for is today and kind of explain it, because there's a couple of instructions. Essentially what you are going to be doing is you are going to be doing what we just did. You're going to be drawing Lewis structures for 6 different covalent compounds. Okay, you have 2 options. You can either use the pear deck and do it just as we have been doing. Okay, I have linked here a self-paced pear deck, meaning you don't have to wait for me to click through each slide. You do it and then you move on to the next one and then turn it in at the end. Okay, and so you can do it through pear deck. Or if you feel like, I hate drawing on the computer, it's driving me nuts, I don't have a mouse, you are also welcome to just use the list of compounds that I've given you and draw them on paper. Okay, if you draw them on paper, just upload an image to this Google Classroom assignment and then click submit. Okay, I want to be perfectly transparent with you guys. All of the answers are on the internet. The point of this is not to go to google.com and look up Lewis structures. The point of this is for you guys to start to figure out how to put these together yourself, because then you'll understand what the drawings mean in the future. Okay, and then if you choose to pursue chemistry, you're going to be making these pictures for like atoms with like hundreds of different elements and yada yada. And so I want you guys to challenge yourselves to do this on your own. Okay, and I'm saying that because I know the answers are there. I know that it's very tempting to go to google.com and just look for the answer. You're welcome to do that to check your work, fine, but I really want to see your process. I'm saying this because I know that you all have the brain power to do this on your own. Okay, just take it step by step, figure out your valence electrons, figure out who goes in the center, and then arrange them so that everybody's happy and you've used the exact number of electrons. Okay, if you are choosing to use the pear deck, each one of them has the lovely little template thing that I just made, which you can use if you want, but you don't have to. If you just want to draw the final picture, great, do your thing. Okay, so at this point, if you feel like I got this, I'm ready to go, you can feel free to leave the Zoom call and work on your asynchronous work for today. Or if you want to see a couple more examples, I can stay until 9:40 and work through 1 or 2 together here on Zoom as well. Okay, totally up to you. But if you are leaving, I hope you all have an excellent Wednesday. I think that's what day it is today. I don't know. And yeah, I'll see you tomorrow. Okay, goodbye, my friends. If you're leaving, if you're staying, just hang out for a few minutes. Okay,